Good evening. Yeah. So what we discussed in last class, tell me once. I just want to look into it once again. We have discussed about molecular orbital theory in the last class, and before that class we have finished valence shell electron pair repulsion theory. So from these two topics definitely there will be one question. You can expect two questions from both of these topics. One question from the valence shell electron pair repulsion theory and one is from MOT. Okay, so I just want to brush up the same things first of all before going to the new topics in this session. Okay, right, just hold on. Yeah. Yeah. So yeah, if it is blur, you just inform me. So what we discussed, for example, I am giving some structures like ICl2 I am giving you, ICl2 minus I am giving you. Now tell me what is its structure and hybridization for this central iodine atom in this. How can we do that? How can we do this? I want for central iodine. What is the valency electrons for this? 7 electrons now. So take 7 dots. 7 dots, and one minus charge is also there. Now add one more dot. Okay. So how many surrounding atoms are there? 2. So one chlorine, other chlorine. The next, this is one pair of lone pair. This is another lone pair. This is 3 lone pairs are there. So now totally how many sigma bonds and how many lone pairs are there? So 2 sigma bonds plus 3 lone pairs. So totally 5. So 5 means it is sp3d. Okay, with sp3d hybridization, what is the geometry we have? Trigonal bipyramidal. This is electronic geometry. But if I this is electronic geometry. Now if I ask you what is the structure or shape, so your answer should be by writing the exact structure shape, you will get the structure here. See, you have lone pairs in the equatorial positions, 3 equatorial position, 3 lone pairs are there, and one axial position, the other axial position we have atoms like chlorine here and here, that's it. So how it is? It is like a linear. How it is now? It is a linear, like line is there now, so you should say it is a linear. Okay. Now if I ask you further, so tell me, for example I am giving you PCl6 minus, or instead we will give some simple one, XeF4. Tell me, XeF4, this is a simple one I can give you. What is the structure? Four sigma bonds and 2 lone pairs you will get. Okay. See, xenon means 8 now. So 8 valency electrons. Okay, 8 valency electron plus surrounding atoms are 4. So 8 plus 4 by 2. You can do it like this also. So it will be 12 by 2. It means 6. 6 means sp3d2. Okay, sp3d2. Out of this 6, how many surrounding atoms are there? So 4. So 4 are bond pairs, remaining 2 are lone pair electrons. Okay, if we have sp3d2, our hybridization should be like structure should be, geometry should be, electronic geometry should be octahedral. Okay, but in this octahedral, so we have 2 lone pairs now. So 2 lone pairs you keep one above the plane, other one below the plane, so that we will get Xe. 4 atoms are within the plane, one plane, one lone pair above the plane, other one is below the plane, and we have planar geometry like this. Square planar will be the structure. What is that? Square planar. Okay, right. Okay, next let us move forward with other things. For example, yesterday we discussed about what we discussed in the last class. Bond, like molecular orbital theory. But for example, I am giving you Cn minus. What is the bond order I am asking? I am giving you Cn minus and Cn, like this I am giving you. So tell me what is the bond orders? Just what I told you, just you can do this by using the trick also. How many electrons are there here? 6 plus 7. So 13 electrons here, and here how many are there? 6 plus 7 and minus 1 is there. So you add one more electron. So total how many? 14 electrons are there. So whenever we have 13 electrons and 14 electrons, so 14 electrons I given you one midpoint. What is the value I given? Maximum order of bond order of 3 at 14. Okay, so here 2.5 because one electron is decreased now. It means we are removing it from bonding molecular orbital. So it means one electron is less here, bond order will be 2.5. Again, if I have only 12 electrons, decrease by 0.5. So it will be 2.0 like that. Okay, so now yesterday I have given you this question: O2 plus O2, O2 minus, O2 2 minus. Tell me for this, what is the bond order? Just count the number of electrons in each case. So here O2 mean oxygen atom means 8 electrons are there. Molecule, right? So it means it should be 16 electrons. Here plus means remove one electron, so 15. So minus means add one electron, 17. Here 18, like this. That's it. Okay. So for 14 electrons bond order is 3. So for 15 electrons decrease by 0.5. So it means 2.5. Okay, it is 2.5. Then here also what happens? Decrease by 2. This one, this one, that's it. So means where do we have maximum bond order? 15 here in this case. So maximum bond order, so this will be the order. That's it. If I ask for bond length giving same molecules, if I ask for bond length, what is your order? Reverse. So bond order is inversely proportional now. So this will be the order. And if I ask for bond strength is same as bond order. More the bond order, more is the strength, bond strength. Okay, like that. And next, stability, if I ask, stability also follows the same order, like same as bond order. Okay, so that's it. Next, what about the magnetic moments? Yes, like magnetic natures you tell me, which is diamagnetic, paramagnetic, like that. So how many valency like how many non-unpaired electrons are there? How many unpaired electrons are there in O2? Yesterday we discussed there are 2 unpaired electrons when it is O2 that are in anti-bonding orbital. Okay, so 2 unpaired electrons here, so it means it is paramagnetic. And what about this? By removing one unpaired electron, still one more unpaired electron will be there. This is also paramagnetic. And what about this? Adding one electron, see 2 are unpaired, third electron is added, it means out of these 2, one will get paired, other will be remained unpaired. So this is also having one unpaired electron, paramagnetic. And what about this? Adding one more electron, so this electron also will get paired up now, so it will be diamagnet, like this. Okay, now what I told you, magnetic spin only magnetic moment formula, mu is equals to root over n into n plus 2 Bohr magnetons. Okay, now if we have one unpaired electron, n value will be 1, like that you take and substitute here, you will get different values. So for one electron you will get around 1.73, for 2 electrons you will get around 2 into 2 plus 2, 4. So 4 to 8, 8 means again it will be around 2.9, around 2.85, something like that. Okay, right. Is this clear or not? Like this you have to solve the questions. If for diamagnetic, no unpaired electron, 0 spin only magnetic moment value. Okay, like this. Okay, right. Next. So now if in case something like this they have given NO2, so they will ask which are the following is or paramagnetic. Which are the following is or paramagnetic? First option, second option they will give NO, and third option they will give B3, BR3, O8, okay, and fourth option they will be giving O2, and fifth option C2, like this they will give you. So what is your answer for this kind of questions? Tell me, what is your answer for this kind of questions? Yeah. So guys, those who are in live, if there is any blur in the screen, please inform me in the chat box. Yeah. So tell me, what is your answer here? NO2 we have now, just check whether any unpaired electron is there or not. Just draw its Lewis dot structure. Nitrogen have 5 valency electrons now, so you just put 5 dots here like this. Okay, so oxygen, each oxygen is divalent, so it makes 2 bonds. Okay, so this side oxygen I am writing like this. Okay, it making 2 bonds like this, and this side one more oxygen I am writing. It also makes 2 bonds. Now how many unpaired electrons are there? 1 unpaired electron is there. So it can be a paramagnetic substance. Okay, and next one NO means, again look at this. So N having again 5 electrons, and oxygen, see it is also having odd number of electrons. Whenever odd number of electron species is there, definitely there will be one unpaired electron. So you can consider this is also paramagnetic right now. So this is also paramagnetic. Then next, what about B3O8? So B3O8, if you look at the structure, so Br, 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 if I draw it like this, and oxygens are like this. Okay, like this, like this. Okay, so now tell me, around each boron, bromine, how many unpaired electrons are there? So in the valency of bromine we have 7 valency electrons, like 1 2 3 4 5 6 7, if I put 7. Okay, so here this 6 bonds, 7 bonds, it means bromine can form a 7 bonds right now. So here 7 bonds are there, all electrons are paired up in this terminal case, and even in this terminal case also. But if you look at the center bromine, just check how many how many bonds are there. Only 6 bonds are there. It means that 7th electron is remained unpaired right now. So it means that makes it to be also magnetically active. I can say paramagnetic substance here, this one also. Is this clear or not? Yes or no? Right. Next, what about O2 molecule? This is based on MOT, molecular orbital theory. So how can you answer that? Tell me. O2 means how many valence electrons are there? So 8 plus 8, 16, like total electrons are 16. Here total electrons of oxygen is 16. Okay, so now in these 16 electrons, so look at here, I can write sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, next sigma 2px, next pi 2py, sigma 2pz I am writing, pi 2p y equals to pi 2px, the next pi star 2p x equals to pi star 2py, next sigma 2p z, sigma star 2p z. So just fill 16 electrons, 2 4 8 10 12 13 14. See, somewhere we are missing something. See, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Next 2 4 8 2 4 6 8 10 11 12 13 14 15 16. Okay, so we have 2 unpaired electrons here right now, so that makes it to be paramagnetic. So this is paramagnetic. Now what about this C2? It is having total electrons less than 14 now. So if total electron count is less than 14, what we need to do? You just need to change this order. So first write pi, then write sigma. Okay, so it becomes, what happens to that? It will be a diamagnetic substance. Okay, and that last 4 electrons are lies in here in this one. Okay, so that makes it to be diamagnetic. And bonds, the nature of bonds between 2 carbon atoms is double bond here. Both of them are pi bonds only. Okay, they will ask what type of bonds present between the carbon atoms in C2 molecule. Both of them are what? Pi bonds only. Don't consider like one sigma and one pi bond. Both of them are what? Pi bonds in case of C2 molecule. Okay, this is a previous year asked question, this one. Okay, and this is diamagnetic, this is paramagnetic here. Okay, so now if I ask, just I am giving you O minus 2, whether it is diamagnetic or paramagnetic. O minus 2. O minus 2, this is not O2 minus 2, it is just O minus 2. Oxide ion. So when they give oxide ion, just tell me, like what is this? Like oxygen contains how many valence electrons? 8 now. So total electron count is 8. Okay, like I can write 1s2, 2s2, 2p4. Okay, so like this and like this. So 2 electrons, 3, 4 electrons like this. 2 unpaired electrons are there. See, we are adding 2 more electrons. So that will also be filled here now. So if we fill it, so completely overall filled, so therefore it will be diamagnetic. So these are very simple questions, but some students will face difficulty to solve this kind of questions, like O2 minus, it's an oxide giving, and they will asking you to find whether diamagnetic or paramagnetic. For example, they will give indirectly like this, Na2O. So tell me whether this compound is diamagnetic or paramagnetic. See here, Na plus like this, 2 Na plus ions are there, and O minus 2 ion is there. So this is also having fully filled electronic configuration. 10 electrons are there, like neon gas configuration, and this is also having 10 electrons now. So this is also having neon gas configuration. All of the electrons are fully paired up. Right now no unpaired electrons, so it is a diamagnetic substance. This is a diamagnetic substance. This is how you need to understand and answer the questions. Okay, right. Let us move forward. Yeah, so today we will be coming back to this later again. So now we will discuss about types of bonds. How many types we have bonds? 2 types. One is covalent bond and ionic bond. Now we will be discussing about dipole moment. In order to look into that, so just look at here, we have covalent bond and ionic bond. Covalent bond is formed by sharing of electrons, whereas ionic bond is formed by complete transfer of electrons. Okay, now a bond is considered to be polar, covalent and covalent bonds are of 2 types. One is non-polar, another one is polar. So when electronegativity difference is greater than 0.4 between the bonded atoms, let us say AB are making a bond like this. Okay, if the electronegativity difference between A and B is greater than 0.4, that is considered as polar bond. More the difference, more than 0.4 is considered as polar covalent. If it is lesser than or equal, then it is non-polar covalent. Okay, right. So now in this polar covalent and non-polar covalent, for example, between I have a covalent bond between 2 same molecules, same atoms, like AA type, like hydrogen. So this makes a bond. See, both of them are electronegativity same now, so difference will be 0. So this makes it to be non-polar bonds. This is covalent non-polar bonds. Whereas if there is some electronegativity difference is there, for example HCl I have. Okay, this is a covalent bond, but electronegativity difference between hydrogen and chlorine will be larger difference. It is greater than 0.4. Therefore, what I can say, it's a covalent bond, but polar covalent. Okay, you got the difference, polar covalent and non-polar. Okay, now we will be discussing about this dipole moment that is arises in this covalent bonds. See, so what exactly dipole moment means? For example, I am saying now HCl here we have, which is having more electronegativity. Chlorine will be having more electronegativity. So the bonded electrons here are dragging towards the chlorine side. So that makes it to be existence of poles, like development of poles here. So here we have partial positive, partial negative charge. Wherever electron density is moving, that should be written as partial negative charge, other one should be partial positive charge. So these are 2 poles, dipoles are generated now. So I can say this is a polar molecule. Okay, next. So polarization, due to polarization what happens? Charged ends are developed, like partial negative and partial charge. So act as a electric dipole. Okay, right. Now the dipole moment here. So how can we calculate the dipole moment for the charged species now? So mu is equals to charge multiplied with distance. Distance of separation between these two charges, this is what d, and charge on the each of that molecule or the ion. Okay, q into d I can say. Okay. Now dipole moment is a vector quantity. What I am saying, dipole moment is a vector quantity. So q equals to, or mu equals to q into d or c into d. So it's a vector quantity, you just remember, we will discuss some questions on that. Okay. So now in case of diatomic molecules, dipole moment depends upon electronegativity difference between the atoms. In case of polyatomic molecules, it depends upon bond dipole. It means bond dipole means what? For example, I have different molecule, like polyatomic molecule, I have carbon with hydrogen, chlorine, and some more hydrogen and some chlorine is there. So now what happens in this case is, it depends upon the bond dipole between these two atoms. We have bond now, so this is partial positive, this is partial negative, and between these two, this is partial negative, this should be partial positive, like this. It depends upon individual bonds, and together we will consider overall dipole moment. Okay, I will show you some questions after some time, but just understand these terms here which I am using. Okay, and another one is spatial arrangement around the central carbon atom, how they are arranged, like we are seeing tetrahedral or square pyramidal, something like square planar or trigonal planar, like this we are saying. Spatial arrangement also very important factor in case of multi-electron, multi-polyatomic system. Okay, so here since I am saying it is a vector quantity, the resultant dipole moment is calculated using this formula. See, this is a theta between, for example, I have a bond B, there is a bond like this between two A atoms. So this side polarity like this, we have something like this polarities. Okay, so now resultant mu is equals to root over this one, this bond distance q p square plus 2 pq cos theta. Like you just remember, if I say this is mu1, this is mu2, so mu1 root over mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Okay, right. So theta represents here between these two bonds what is the angle. Okay, right. So just look at here. Here we have central atom A, around we have B atoms like this. Okay, around we have B atoms. Now all surrounding atoms are same now. So what is the hybridization of this central atom here? There is no lone pair, only 4 surrounding sigma bonds are there. So I can say hybridization will be what? sp3. So sp3 means tetrahedral geometry, right? So it is a regular geometry without any lone pairs right now. So if any molecule, any polyatomic molecule is there, if it is having regular geometry with all surrounding atoms are same, then its dipole moment will be 0. For example, methane we have. Methane I am writing, like this we will write. So all surrounding atoms are same here around the central atom. It is having perfect geometry, regular geometry, tetrahedral. Therefore mu value will be in this case 0, because these dipoles will cancel out each other. Okay, dipoles which are generating here will cancel out each other. Therefore resultant dipole will be 0. Okay, not only this one, even if I write CCl4, see surrounding atoms, see bonds might be polar, but overall molecule will become non-polar due to resultant cancellation. Okay, see these bonds might be polar, like bonds might be polar depending upon the electronegativity, but due to their electronegativity difference we are saying these are polar, but overall molecule will be cancelling out each other. Therefore it becomes 0 when it is having regular geometry with all surrounding atoms are same. Is this clear or not? Even if I say trigonal bipyramidal means how it will be, PCl5 is the best example I can say, trigonal bipyramidal. This is trigonal bipyramid means like this. Okay, see it is having like this. Okay, PCl5 now, so PCl5 means all these are Cl, 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 C, Cl, and here also Cl. So these between these two dipole moment will be like this. Okay, they are cancelling out each other, and you know, between here, this side will be here and this side will be like this, but these two mu's are there now, they will be, resultant mu will be this side, so which is exactly equals to the amount of dipole here we are seeing in opposite direction. Therefore it cancel out each other, makes it to be 0. What it makes? 0. Okay, mu net will be 0 in this case also. Okay, so you just take the simple example like BCl3 or BF3, these molecules are also having mu is equals to 0. Why? Because, so what is the hybridization of boron here? sp2. What is this? sp2. sp2 means trigonal planar. Okay, trigonal planar means boron in the center and you are writing it like this. Okay, fluorine and fluorine here. Okay, so now see, this bond will polarizes like this and here also it will polarizes like this. So the resultant mu for these two bonds will be this side, which is exactly opposite side. So mu net will be 0 in this case also. Okay, like this. So now if I want to give you some other compounds like this, see, first of all I am writing a benzene ring like this. See, in this benzene ring all the carbons are like formula is C6H6 now, all these carbons are having 1 hydrogen right now. So therefore there is no net dipole moment. Net dipole moment for benzene will be mu net will be equals to 0 in this case. Okay, but when it comes to any group is attached to the benzene ring, what it makes is, see, this cyano group is more electronegative, so it is electron withdrawing group and drag the electrons towards itself, so makes it to be mu net not equals to 0. So it is a having a non-zero dipole moment. Okay, now if I look the same groups I am placing at the para position to this. So look at here, cyano group is nothing but cyanide is having what hybridization between carbon and nitrogen. We have 3 bonds like this. So it is sp hybridized. What is that? sp hybridized. So linear na sp hybridized means the dipole moment will be moves like this and here also moves like this. Therefore they are cancelling out each other. Mu net will be 0. When it is 0, they are, if they cancel out each other. Okay, so now we have, I am generalizing this kind of explanations, this kind of things by giving different examples. See, I am writing this CH3 group here. Okay, both groups are electron releasing groups now. What they are? Both groups are electron releasing groups. I will give you one simple way to remember them. CH3, CH3. See, when they are adjacent to each other, you should say them as ortho substituted, ortho dimethyl benzene. Okay, this is meta substituted, meta dimethyl benzene, and this is para dimethyl 1,4 dimethyl benzene. Okay, so for this your mu net value will be, mu net order will be, you just remember ortho, meta, para. Okay, I will tell you why that order is. Okay, so you just remember OMP will be the order of dipole moment in the case of when both groups are electron releasing groups. If both this type of groups, I am generalizing this example using like this, G and G. Both G's are what? Both are electron releasing groups only, or both are electron withdrawing groups. Both should be of same nature, either electron releasing and electron withdrawing. Then only this like order will be applicable. Okay, so now what is that formula we have learned? Mu net equals to root over mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Right now, so mu net is directly proportional to root over cos theta. So it means if we look at the cos theta values, as theta value increases, cos theta decreases. Okay, so mu net directly proportional to cos theta and inversely proportional to theta I am writing just for understanding purpose. So more the theta, lower will be the mu. Okay, so these are something like inversely related I am saying. Okay, so based on this, see, this is electron releasing group, this is also electron releasing group. So what is the resultant theta here they are making? This is a resultant theta. So what is the resultant theta we are going to get? That value you need to check. Okay, so more theta, see here you are getting around 120 degrees. Okay, like this. So based on this, theta is inversely proportional to mu net. Now based on this we got this order. What is the order? Ortho, meta, pair. So which is having maximum? Ortho, next meta, pair. When the groups, when the G groups are, one is electron releasing and one is electron withdrawing group. For example, I am taking one methyl group, the other one is nitro group, like this. So whenever we have some G group, one is electron releasing and electron withdrawing groups are there, different groups are there. So here G and G dash I am saying. Okay, if G and G dash are not of same type, G and G dash are not equal, okay, then in this case we will get PMO. What is the order of dipole moment? PMO. What is this PMO, sir? Let us see here one example. This is ortho substituted now. I am giving one more meta substituted group like this, and the other one is para substituted group like this. Tell me in this case A, B, C. What is the dipole moment order? Which is para substituted? 1,4 is called para. So this is para. So it will be having maximum mu. After this, M will be in between in each of the case. There is OMP, this is PMO. So here B. Meta means 1, 3 like this. 1, 2, 3. Okay, after that A. So like this. Okay, just we need to identify whether they are electron releasing groups or electron withdrawing groups are of different types. Just identify the types and you can write the answer, that's it. Okay, now look at this. I am writing here CH3. So mu not equal to 0 in which are the following cases? This is a question I am asking you. Okay, so A, CH3, CH3, tell me, in which of these cases mu not equals to 0? See, if it is simple benzene, mu equals to 0, but one group is there now. So due to that reason, mu not equals to 0. And in this case, see, this side releases this side and like this. So mu not equals to 0 here also. And in this case, so why? Because this is a linear molecule like this. So drags this side, this is also drags in the opposite direction, mu equals to 0. And here it looks like mu equals to 0, but if you look at the structure, it gives you the proper orientation. See, hydrogens are like this and it is having lone pair electrons here like this. So that makes it to be non-planar. Okay, so it means this is direction is this side and this direction is something like different directions are there. Okay, so yeah, different directions are there. So it makes mu not equals to 0 in this case. Mu net not equals to 0 in this case. Here both groups are of same now, like a ball, like a sphere you can consider. So mu equals to 0 in this case. Like this we can able to identify. Okay. Now next thing is, you just look at these molecules and tell me Cl, Cl, so tell me what about their order? What about the dipole moment order? both of are a same group now, same nature. So it means what is the order I given? The short tricks I given now. OMP, PMO like that. So they are both of same. Then ortho, meta, para. Okay, OMP. That's it. Okay, so it means this is ortho now. So A, B, C like this. Okay, next. Now I will be giving you something like NH3 and NF3. In this case, tell me which is having more dipole moment. Mu will be more for which compound here? See, NH3 case, we have lone pair electrons here and 3 hydrogen atoms here, and here N, F, F, F like this. Like this. Okay, so now tell me dipole moment moves which side? Like this. Okay, but what about here? Because which is more electronegative between hydrogen and nitrogen? Nitrogen now, that's why dipole moment is moving upside. But in this case, fluorine, so this is moving downwards. Okay, and whenever we have lone pairs will drag the electrons towards themselves. So it means they are moving, complete dipole moment is moving upward in the first case. But here lone pairs are dragging upwards, fluorines are dragging downwards. They are cancelling out to some extent, not exactly, same forces are not equal here, but they are cancelling out to some extent. So here dipole moment is getting cancelling out to some extent, but here it is resultant is added. Therefore more mu will be seen in which case? NH3 case. Okay, so this will be the order like this. Okay, right. Okay, will you answer this question then? H2O and OF2. So what is the dipole moment nature? Same story, whatever you have understand here, apply that here. Towards oxygen side, and this is also upward. So total mu is upward, but here downwards, this is upward. So now what happens? Here cancelling out, but here not cancel. So here it is added up. So mu net will be more in water than the OF2. Okay, right. Next we will move forward. What is the use of dipole moment? So if dipole moment increases, the boiling point of that molecules also increases. Okay, for example, I am giving you like different molecules. Just now you have seen here now. So in this case, so dipole moment depends upon what? What is that? Boiling point depends upon what? Dipole moment. If more dipole moment, more is the boiling point for that. Okay, yeah. So here you have this OMP order now. So based on this, you can give boiling point order also. Boiling point for O is greater, then meta, then pa, like this. Okay, more boiling point, more dipole moment, more is a boiling point order. Okay, right. Let us move forward. We will discuss about hydrogen bond. So this is the one last formula we can use. By using dipole moment values, we can also find percentage of ionic character. So percentage of ionic character equals to mu observed by mu theoretical. So mu observed, how can we calculate? That formula is there, like mu theoretical, how can we calculate? Mu theoretical equals to, or they will give mu theoretical value, and they will, one of this value they will be giving us, and other value they will asking us. So you can use this charge into Q into D. By using this value, you can substitute here and we will get the answer. Okay, right. Okay, next one is hydrogen bond. So what is hydrogen bond exactly means? hydrogen bonding. Hydrogen bonding. So what exactly hydrogen bonding means? It is an electrostatic force of attraction between hydrogen atom that is attached to, it is bonded to electronegative atom and the other electronegative atom. It means, for example, very simple, it might be confusing, but look at here, very easy. For example, I have a hydrogen atom that is attached to the fluorine atom. We know fluorine is more electronegative atom, therefore that generates partial negative charge on fluorine and partial positive charge on hydrogen. Okay, so this is what dipoles are generated here. Right now, due to electronegativity difference, we got these dipoles. Okay, now this hydrogen, see the electrostatic force of attraction between hydrogen atom that is bonded to electronegative, hydrogen atom bonded to the electronegative atom here. Okay, and this one will be having some electrostatic forces with the other electronegative atom. For example, I am keeping this molecule in the water, for example. So oxygen is also electronegative atom now. So oxygen present in the water molecule here will be polarizes like this is partial positive and partial negative here, right now. So here also positive, negative here. Now due to this presence of lone pair electrons here, that will having more electron density, right, partial polarities are there. So between this polarity and this polarity we have electrostatic force of attraction. So this type of attraction comes, they will come close right now, like a bond only it is. Okay, so now this is what we are calling it as hydrogen bond, hydrogen bond. Okay, now we know water, see, you know oxygen belongs to which group? 16th group, right now. Oxygen, what are the other elements we have? Sulfur, like this we have. Now if I take the hydrate of oxygen is H2, similarly hydrate of sulfur is H2S. Now if I consider H2O, this is in liquid in state, but whereas water is liquid only now, but whereas this H2S is a gaseous state. Why? What is the reason for this? Because in water we have hydrogen bond. What we have? Hydrogen bond. Whereas in H2S there is no hydrogen bond, so therefore it exists in gaseous state. Is that clear? Okay, so now these hydrogen bonds are of two types. How many types I am saying? Two types. Okay, one is hydrogen bonds are two types. One is intermolecular, other one is intramolecular. So what do we mean by inter and intra? See, between two different molecules, between two molecules we can say inter. Within the molecule means intra. Okay, between two molecules means, for example, water molecules I have. This is one water molecule and this is other water molecule here I am taking. Okay, see, this will get polarizes like this or not? Here also negative, this is positive, this is positive, this is negative. See, between this hydrogen and this oxygen, do we have electrostatic forces or not? Yes. So this is what we are considering it as hydrogen bond. Between two molecules now, molecules may be same or different, that is not a matter here. Between two molecules or not? Between this is one molecule, the other molecule. Between them we have hydrogen bond. We can say it as intermolecular hydrogen bond. Now tell me between HF and H2O. Inter or intra? Inter only. Between two molecules now. Between water molecules, inter. Between two molecules, right? That is inter. So now what do we mean by intra here? See, for example, I have something like benzene ring having one OH group over here and one nitro group over here, like this. See, we know oxygen and nitrogen, oxygen will generates negative charge on it now, okay, and hydrogen will be having positive and this is negative. So between this hydrogen and oxygen, what we have, like hydrogen bond is exists right now here. This is what? Hydrogen bond. But what type of hydrogen bond? See, this is completely taking within the molecule. These are two different pieces. This is one piece, this is another piece, like two different molecules, two molecules. But here this is happening within the molecule right now, like from here to here, like this, something like this, okay, right now. So what we can say, this is intra, okay. So now due to the Panchami, you are asking something in the doubt session in the chat box. So there is nothing like one is stronger, other one is weaker. It depends. Relative stability or relative strength will be varies here. Always your statement is not correct here. Okay? Yeah, look at here. So now due to this inter and intramolecular bonding, there are some applications. You know, the boiling points are there now. So due to intermolecular hydrogen bond, H bond, boiling point increases, whereas due to intra it is decreases. Okay, so now I will be giving you two molecules and I will be asking what is the boiling point order. So simple one, you just take here orthonitrophenol, paranitrophenol I am giving you. See, now tell me, between these two molecules, between these two species, these two parts, do we have hydrogen bonding or not? See, they are very far from each other now, but they are far from each other. So something like this, if it makes the bond is not stable, that is having very weak interactions, okay, or no interaction. But here they are very adjacent to each other, so here it is possible. Right now intramolecular exists here and there is no intra here, but if I consider this is a having in a beaker, okay, like this we have substituted paranitrophenol. There are many molecules now. If I say a bottle of water, in this there are lot of water molecules are there. Similarly, if I take the liquid like solution of this paranitrophenol, there will be n number of molecules like this right now between this molecule and the adjacent molecule, adjacent paranitrophenol. What do we have? Between these two, what do we have? Hydrogen bonding exists now. So this is what? Between two different molecules. So inter or intra? Intra. Between two different molecules now. So it is inter. See, this one is and this one. So this is what? Inter. Okay. But this is within the molecule. Intra. Okay. So due to inter and intra, what happens to the boiling point? See, due to intermolecular hydrogen bond, boiling point increases. See, I have molecules. This kind of molecule, there will be n number of molecules. Between all the molecules, what we have? Hydrogen bond. So in order to vaporize that, we need to supply high amount of energy. Why? Because we need to break these bonds, these hydrogen bonds. So in order to break these bonds, we require to supply high amount of energy, then only bond breakage takes place, then that molecule slowly converts into gaseous phase. So therefore I can say boiling point will be more in case of when if it is having intermolecular hydrogen bonding. But if it is having intramolecule, they will themselves bonds make their own bond now, so that overall molecule weight get vaporized or converts into gaseous phase easily. That's why intermolecular hydrogen bond increases boiling point. Remember this point. Okay. So those who are watching in online, if you are clear with the concept, just click on the like button. Okay, and the next thing is, here I told you water exists in liquid state. So why? Because of hydrogen bonding. What type of hydrogen bonding? What type of hydrogen bonding? Two different water molecules will be there now, like this. So it will be intermolecular hydrogen bonding. What is that? Intermolecular hydrogen bonding. Okay, that's it. You just remember. And it will be having like a cage like structure. So whenever in the ice, you know, ice water forms like in the solid state it will be ice. Now what about the water in its solid state and liquid state? The ice will floats on the water. Why? What is the reason for that? Because when it is forming that ice crystals, that having that volume or like whatever the ice crystal we are seeing, in that case the volume will be expanded for that. So it will be having like a cage like structure, like water molecules, between the water molecules there will be hydrogen bonding. Due to that their volume increases like this. Okay, if volume increases, what happens to the density? What happens to the density? Density equals to mass by volume. See, if volume increases, density decreases. Okay, so if density is decreasing, that particular species will floats on the water. The one which is having lower density will be floats on that particular liquid. So water in liquid state and water in solid ice form, the volume of water in liquid state will be smaller than the volume of water in the solid state because of intermolecular hydrogen bond. They has cage like structure will be formed. That makes it to be have more volume, lower density. That makes it to flow on the water. Okay, this is what the reason for floating of ice on the water. Okay, remember this, right? Let's, yeah, so this is about the session. Do you have any doubts here? Anything? No doubts. Okay, so I can wind up. And those who are watching online, if you are new to this channel, please click on the subscribe button, and if you like the session, just click on the like button also. Thank you for watching.